So now let's discuss a case where the direction of the particle, the direction of the initial velocity of the particle is not perpendicular to the field. In such a case, the velocity component parallel to the field is constant because there is no force parallel to the field, and the particle moves in a helix this path. This is the helical motion. The radius of the helix is given by the same equation, where v is the component here in this case is the component of velocity perpendicular to the magnetic field. The velocity vector of a particle in this case is resolved into two components, one parallel to b and one perpendicular to b, and the parallel component determines the pitch of the helix, that is the distance between adjacent turns. The perpendicular component determines the radius of the helix and is the quantity to be substituted for v in the above equation. Yeah. And now let's discuss one more complicated case where motion of a charged particle is in a non-uniform magnetic field, and this is definitely it's very complex case. Here a field produced by two circular coils which are separated by some distance. Particle near the coil, either this or this one, experience a magnetic force towards the center of the region. Particles with appropriate speeds spiral repeatedly from one end of the region to the other and back. Because charged particles can be trapped in such a magnetic field, so this is called a magnetic bottle. This technique is used to confine very hot plasmas with temperature of order of 10 raised to power 6 Kelvin, and in using the same in a similar way, you can say the Earth's non-uniform magnetic field traps charged particles coming from the sun and in a donut shaped regions around the Earth. These regions are called as Van Allen radiation belts, and they were discovered in 1958 from the data obtained by instruments abroad. The satellite name was Explorer 1 satellite, from that it was obtained. And the magnetic forces on charged particles play a very important role in study of elementary particles. For example, in this case, this is a photograph of a bubble chamber, which and in this bubble chamber it is filled with liquid hydrogen, and a magnetic field, a very strong magnetic field is applied, which is directed into the plane of the photograph. A high energy gamma ray dislodges an electron from a hydrogen atom, sending it off at high speed and creating a visible track in the liquid hydrogen. The track shows the electron curving downward due to the magnetic force. The energy of the collision also produces another electron and a positron, a positively charged electron. Because of their opposite charges, the trajectories of the electron and the positron curve in opposite direction. So as the particles flow through the liquid hydrogen, they collide with other charged particles, losing energy and speed.